Okay, this is going to be a solve of Knife Thrower. So this is the round of 32 in the PM session. We have a board that rotates. You throw knives from any of the four sides, north, south, east, west, and you will hit the first number that you come into contact with a knife. I just filmed basically a whole solve of this, but I had a crash at the end, so I'm going to do it again. There's an error in Excel where if you type something like equals A1 hash, this is trying to refer to a spilled array, but it's not there. Obviously it gives me a ref error. If I come back into that cell, press F2 to enter it, or double click, my Excel has now crashed. So whenever I have a data table approach that uses dynamic arrays with this hash symbol, if the question changes, or in the data table the question changes so there would no longer be an array there in something I've built, then we get this crash. So I'm going to build this in a non-dynamic array way, which might look weird, but it's just so I don't crash with my data table approach. Okay, so if you're watching this, I won't explain too much. I will use a rotation lambda for this, which most people have, but mine has a very handy addition for this case. So if I import my lambdas, and I say equals rotation, or rotate this array, so if I don't put anything else, it will just rotate it by 1. So let's just format painter so you can see this. So I'm going to say let A be that. If A equals 0, do blank, otherwise do A. I can then rotate it 2, 3, 4, 5 times, whatever I like. If I did 5 times, it would come back to 1. It just kind of cycles. I can do negative rotations for the other direction, so -3, for example. And the other cool addition that I have that other people don't, at least I don't think they do, is I can input addresses. So I could say, where does cell C1 go, for example? So if I say C1, with that rotation, it tells me C1 will go to AQ3. So this C1 will rotate round to this AQ column, and it will land in AQ3. And that will take in any kind of array of addresses and keep them in the format they're in. So if I just say if this equals blank, do blank, otherwise do address of cells that will give me the address for everything. And then if I said rotate that and I want this to be my cells, it's going to tell me, okay, this will go to AO22. So it's currently V3, it's telling me V3 will go to AO22, which is around here, with one rotation. If I change that to 2 rotations, obviously it would go to the opposite side, it would go down to V41, which is here, and so on. So that's going to be very handy for this case. So what I'm basically going to do is build up a table that's just the name of where we throw from, according to the case. So it's kind of in this notation, north, south, east, west, then a number, which corresponds to these numbers up here. What cell we're standing in, and what cell the dagger will land in. And when we come to rotations, instead of rotating the board, I'm going to rotate the player the opposite way. Because if I was throwing here, for example, in column AD, I would throw down and hit this 19. I could use that lambda that I just showed you to tell me, okay, what's going to come into that position might be something up here. 11 would rotate down and come into this 19 position, but what I will actually hit is something on this green diagonal wall here, because that will come in above. So when the board rotates, the knife doesn't land in the same cell, it lands somewhere else, depending on what number comes into view. So if you rotate the play around instead, you don't have that problem. So let's build it. North, south, east, west. I want to gather all the top numbers if you were to throw from the north. So I'm going to say equals bicol, here's my grid, lock it, and then say lambda A, 2col A, 3. So what that will do is it will 2col each of the columns here 1 by 1, get rid of any blanks, and then I want to take the first one of those. So I can say take first row, and then let's drag that all the way down for these, and for south I'm just going to take the last row instead. So that will give me everything along the bottom here, then this 20, and then all of these diagonals up here. And then for east, we want to say by row. And then here, instead of 2col, it's going to be 2 row. And we're going to take the last column instead. So that's going to spill down at the minute because it's everything we hit here in this order. So let's just 2 row that whole lot. And then if we drag that down, we can just change it to be the first column instead of the last, and then we kind of have our mapping. And then next I want to get the addresses for everywhere we hit. So I kind of already have that set up from just showing you my rotation lambda. So I'm going to do the same thing but on my address map. So let's just pull that down to here. Yep. And at the minute I'm capturing all these blanks because they're not real blanks. So instead of this blank here, I'm going to say NA, just so that 2col actually gets rid of them. And then I'm just going to copy this bit into all the other formulas. There we go. And then we should have everything. So just label up area, target, standing, points. Our area is going to be 2 col of this and a sequence of 39. We also want to put a colon in the middle to match these questions. That will just make it easier for later, so let's do that. So and a colon and that. Our target is going to be 2 col of this. Our standing is going to be vstack 2 col address of cells this, 2 col address of cells this, address of cells from the east, address of cells from the west. So that should be where we're standing, and then our points is going to be 2 col of this. So let's just make these all named ranges, Control Shift F3, and then let's actually do the case. So question 1 is just asking what our score is, if it's valid. So if anything says an N, we don't add the number. If it's a V, we do. So I'm going to say if left of this equals N, do 0, otherwise do extract numbers of these and sum that whole thing up. And I'll be using quite a lot of my lambdas in this case, but I have a whole video on that explains all of them and the file if you ever want to use them. Bonus question 1, how many throws are not valid? So that's going to be count occurrences of N in concatenate all of this stuff. So that's 44. Question 2 is just asking what the points are for these locations. So we now have our table, so we can say xlookup these in our area, give me the points. And then we also have a question here in level 2, which side is most used. So we can say at most of text before all of this stuff, and we want a semicolon. So that's the north side. And in question 3, we want to start hitting like 10 things in a row. And I know that later we're going to start bringing players in. So I'm just going to make a model straight away now. So we are going to go, before I had a question, 2 col, I might just start saving this file in case I crash. 2 col of this. So let's do area, standing, and then let's do rotation for later. New standing, and then we'll do target, valid, and let's do points. So standing is going to be xlookup this in area, give me standing. There we go. Rotation for this question is 0, but I'll fix that later. Our new standing is going to be, we'll just set it up now, rotate this array. Let's lock it for minus where we're standing, or sorry, minus the rotation, because we want to rotate our person the other way. If the board's rotating clockwise, we want our person to be anti-clockwise. And our input addresses is where we were standing before. So this is where P1 will go to with that rotation. So if it rotated once, P1 would move to A28, for example. That's the power of that rotation lambda I have now. My target is going to be xlookup this in standing, give me target. Valid is going to be exists this in anything from before, and I'll lock the first cell. Actually want not exists, because if it doesn't exist there, that means it's valid. Then my points is going to be xlookup the target in target, give me points, times whether it's valid or not. So where it's not valid, we'll get 0. And then we should just go sum of this. Let's just save it in case anything breaks with these data tables. And that should be our answers for question 3. I think we also have a bonus. How many throws from the east side are valid across all games? So let's just do that here now. So equals text before this equals east times this. So that's where it's valid. So then we just want to do the sum of this and add it for all games, which can be 48. And in question 4, we have 2 players come in, and we want the maximum score between the players. So example 4, let's just drag this stuff down. Let's do player 1, 2. Whoop, I was a bit worried I was going to crash. I'm worried I'm going to crash every time now. Oh, there we go. This is going to be from 61. And I'll gather the points for player 1 and 2. So let's do player 1 and 2. So I could use a sum if here, but it doesn't play very nice with kind of data tables and arrays. So I'm actually going to do filter the points where the player equals this. Let's lock everything except our player. And I want to sum that. So let's sum it up. Now I want to take the max equals max of this. I think we're going from 81 here. So let's do 81. Are we not? No, we're going from 61, my bad. So hopefully 165 is the answer. It's not, it's 185, so I've done something wrong there. Let's check that. Ah, I left a rotation in here, so we don't want to be rotating yet. So now we should have the right answers. Question 5, we now have this rotation come in. So now we're going from 81, example 5. Let's just save it before we get a terrifying crash. So now our standing is going to be XLOOKUP text before this, and it's going to be colon, last instance of it. Our rotation is going to be extract numbers of this with decimals. I want to take the last number that comes out of there. So that's 11.5, so I'm just extracting the numbers. It's always going to be the first number, 8, and then 11.5. I want to times it by 2 because the rotations are in denominations of pi, where half of pi equals 1 clockwise rotation. So that's that. So now we're standing in A10. Our new target is O10. Of course, it's valid, so we get 27 points. So the points is going to be this. And as you can see, this is pretty quick now. So example 6 is the same, but we have 10 throws. So we do example 6. This is going to go from 101. Drag this down. And I think the rotation carries over. Let me just check that. Yeah, so the position of the board always carries over. So I need to plus whatever rotation we had before, and that is going to carry down like so. And then the points is actually now going to be the sum of all these points. So let's copy that in. And we have a bonus for level 6 as well, which is how many throws are not valid across all games. So I want to go equals sum of minus minus not this. And the sum there is 9, so only 9 not valid. It's a bit of a surprise. 9. There we go. And in question 7, we are back to the 2-player game, but with rotations. So let's do example 7. This is going to go from 121, and let's drag all of this stuff down. So that should be good. And then our player is actually going to be a little bit more complicated, because if a player's cumulative score after a valid throw is divisible by 10, they get another go. So the first player is always going to be 1. Let's do cumulative points. So I can actually steal this formula, I think. So let's do that. I'm just going to delete that out for a second. So cumulative points, I'm going to say filter that where that equals the player. And I'm going to say if this is valid, it was a valid throw, and this is divisible by 10, mod that 10 equals 0, and we need a bracket there. Then give me this player. Otherwise, if that equals 1, give me player 2. Otherwise, give me player 1. So that's just going to swap the player. And I should just be able to do that. we get an error right away because we haven't filtered this down like so. So that needs to go J5 static, and that needs to go K5. There we go. So here, player 1 gets another go because their score's divisible by 10. Let's do our player 1s and 2s again, equals sum of filter. Actually, we don't need to do any of that. We can just do the max of this cumulative points, can't we? Yeah, so equals max of cumulative points. Let's just drag that up there, actually. And our data table doesn't seem to be working, so let's just do it again. Pray we don't crash. Let's actually save it before we do anything. Okay, we have an answer. Let's see if it's right. Okay, nice, that's right. And then the final bonus is, in level 7, how many extra turns are taken by player 1? So extra turns by player 1, they're going to say this equals 1 times this equals 1, and put those in brackets. So if they're both the same, that's an extra turn. So there's an extra turn here, and so on and so on. I should do equals sum of this. This is player 1's extra turns. Data table's a bit slow. There we go. So it should be the sum of all of those, which is 39 and 39. There we go. There's a full score. Yeah, pretty quick with that rotation lambda. I am really annoyed that like data tables don't work. But I mean, if I build this dynamically, yeah, it's just going to crash. It's this stupid bug that I really want to be fixed. I might just roll back to an old version of Excel again, where I don't have that bug because everything works. I don't know how a version has been released where stuff doesn't work, but anyway, I'm moaning. That's it. There's one more case to go, which is the crab case from Nick Boberg. I'll do that at some point, and then we are all caught up. So I hope you enjoyed.